Hello everybody, and welcome to the fourth video of the DIY CNC machine series. This one covers all the electrical and all the work we put into our electronics and wiring in order to make this thing work. So to start, here's a video of me the day we got all of our parts. I started immediately assembling them. You can see the stepper motor drivers are the green things in the background, and then I'm wiring with a lot of excess wire. I used a lot of wire in this that I probably didn't need to Wagos, which this was the first time I used them, and they're really, really nice. They made everything really convenient, and it just all snaps together. So that was lovely. And here's a image of the just kind of in the basic stages of the wiring. You can see off to the right, there's the power supply that all the power to the machine from the wall goes into, and then that's hooked up to each motor driver so they can actually provide power. This is a close-up of one of those motor drivers. There's a lot of pins, but surprisingly, almost all of them go to ground. And then here is the general wiring diagram for the entire machine. You can see it all comes from one wall socket. We used a power tool repair cord to provide power, and then spliced in our emergency stop and general power button, which you can see on the red line, before it gets to the power supply, so there's no chance that anything could really be doing anything. We found out later the power supply has big capacitors in it, so the shutoff wasn't great. But anyway, out of the power supply, that provides a 24-volt output current that goes to each of the motor drivers, and then spliced off the X line, there is a voltage regulator or step down, which converts the 24-volt current into 12-volt current, and that is an acceptable voltage for the Arduino, so that works out great. And then in terms of off there, in this diagram, it shows the voltage that's being used to power the Arduino also going to the limit switches, and then the ground also going to the limit switches, which isn't how you do it. You have to wire signals to each limit switch, which are still there. It's just you don't need that power then. So in terms of the limit switches, they're still powered from the ground, but then all the red voltage wire connected to that Wago. Oh, yeah, all the blocks, by the way, are Wagos. You can see the circular ones I meant to represent like 3-pin Wagos, and then the bigger blocks are 5-pin Wagos that are larger, and those are mainly used for ground because we had a lot of grounds. As I said with the little stepper motor driver image, almost like half of the control pins just go to the ground on the stepper motor drivers, and then the other half plug into the Arduino. Somehow the Arduino Uno was able to actually have enough pins to supply this, but I'm pretty sure we're basically out of pins. So yeah, and then in terms of the rest of this diagram, you can see the Z is actually connected into the 12-volt power that's going to the Arduino, so that's on purpose because the Z ended up being a NEMA 17, whereas all the other stepper motors are NEMA 23s. And we decided that it didn't need as much power, and we haven't had any problems with that. Additionally, you can see the Y1 and Y2. As we said from the very start, we wanted to dual drive our Ys, so these are linked in terms of signal. It's basically a Y lead that the signal and direction pins go from one pin on the Arduino to both input pins on the motor driver. And yeah, that's the fundamentals of this electrical design. It's pretty straightforward. I got this done in about 2 hours. One night I felt like making it, and then we had already ordered all of our parts, so it was really a matter of putting it all together, and we printed this out and got to work. So this is obviously a bit of a jump, but here you can see we're on my dining room floor, but everything is starting to be almost completely wired. So there's no stepper motors wired in this video yet, but I'm setting up my Arduino, making sure all the pins are working correctly. Interfacing, we're using universal G-code sender, so you can just see on my computer me starting to deal with like interfacing to the Arduino and making sure all the stepper motor drivers are like detected. And then we start wiring direction and then the like pulse pins to tell it the amount of steps and the direction that we want it going, which you can see us doing here. It was a little tedious, but since we had already done the wiring diagram, the main challenge was actually setting up GRBL, which you can see I'm going through every single text file possible. It took a little bit getting used to, but then we ended up getting this, which is a video of it working.
It's moving.
It's moving very slowly, but this was the first movement we got with it. We were moving, I believe, one of the Ys, and then very rapidly changing. This was an electrical box that I designed, because as you saw in the previous videos, it was very, very non-organized and scattered on the floor. So I designed, you can see the CAD here, a little electrical box that we can snap Wagos into, and it had a wire channel, and all of the stepper motors were, the drivers were mounted on the side, and it just generally made everything a lot nicer and cleaner and nice to look at. It looked really pretty. We used a bunch of inline Wagos because we were anticipating we might have to, like, for transportation, unplug all the electrical boxes stuff and separate it and move it, but then in reality that's too much work. So the Wagos are kind of just there as if you need to change or unplug something really quickly, you can. But yeah.
All right, so we're gonna try homing now for the first time, because all of our limit switches work. It's all wired, yeah, and everything's working. So in GRBL we have it set up right here. Negative X, negative Y, negative Z, because that's where all of our limit switches are, here, and there. And we're going to, I'm gonna have my hand on the abort button. We're gonna see how this works. Yeah. Make sure my computer's plugged in, because I'm gonna be by. All right, 3, 2, 1. It should go this way, this way.
Yeah, so I ended up blocking the view, but we were basically just testing homing here, and yeah.
Okay, after a few more failed homing attempts, we're doing it again. My push-off distance is now up to about 5 millimeters, because I'm pretty sure the X has a slightly different one, and it's triggering everything.
The push-off is like when it hits it, it clicks it, and then it has to come back up off it to tell it that it came off.
And the X is a little bent, so it's not coming all the way off. And there's Z. And now we're tuning X, which has just hit.
And doesn't want to move off it. Oh, no it does. Micro tuning the X. That's right.
Click. Hello. X triggered.
And Y, I think, triggered the micro also.
I think that worked.
Are we homed? 0, 0?
I think so. Home your machine, and then move it to the maximum safe direction. So home.
Oh, this might take a second.
So for reference, we're just using the setup wizard in UGS, and yeah, it's pretty straightforward, but the soft limits were weird.
So every single one does a fast and then a micro.
Yep. And now we're doing our soft limits, which are the sides that don't have limit switches on them.
So we're micro tuning both X and Y at the same time.
These ended up not really working, so we don't run with them now. They're weird.
Yeah, so the limit switches were absolutely, like, going crazy.
Yeah, they're kind of bugging on us.
For a long time. Oh, hello. I can't move any further. Setting the soft limits for the first time, so I'm not sure how it works.
Yeah,
But,
so the limit switches were triggering when they aren't supposed to trigger, because the signal was being kind of scrambled up with all the separate wires, and so we had to buy a shielding, which is this.
It's
silver,
silver, like copper infused shielding, something or other.
Yeah, it's like a metal mesh of some sort that helps keep all the signals.
So
where
we
they're
were encountering a ton of electronic interference, which is fairly common. A lot of solutions that people have done previously include, let's see, there's these limit switch isolator boards that usually work, but the one that's traditionally used we were unable to find online. and the one that everyone recommended we really could not find. So we went with just shielding the cable and hoping that it works.
Yeah.
And now it so far has been pretty damn good. We haven't had any actual issues. So
Yeah, and as we're finishing our tuning, that was really the largest issue we encountered was electromagnetic interference. And that was solved by the shielding. That's worked perfectly. We also electrical taped a few corners where there was like contact between some metal, and yeah, didn't have any problems after that. This video is actually our first cut. This was not done like under controlled power. This was me with a jog controller in UGS pressing a button to go forward while the router was on. But we did this test on wood, and it demonstrated that our machine was actually capable of providing the force to move the router to at least cut wood. So we were really happy with it. You can see it's just a little, we just moved in a square. And yeah, so that's the conclusion of all the footage we have. But I would like to talk a little bit more and kind of lay it out in a linear um, step, and feel free to click away now, but I'm just gonna, for those interested, explain a bit more the technical side. So we're using three NEMA 23s and one NEMA 17 for the entire build. Two of those NEMA 23s are running the y-axis and one is running the x-axis, and we're using our NEMA 17 for the z-axis. We're using, I believe, TB6600s for that. That's the type of motor driver. They seem to be pretty reliable. We didn't really mess with any of the switches on them or anything at all. I believe they're just in what they came with. And then in terms of limit switches, we just bought random limit switches off of Amazon. They're nothing special. Um, yeah, the wiring is honestly way more straightforward than I was expecting. The only bit we really had to think about a little was the DC to DC converter that took the 24-volt input and outputs 12 volts so we could power the Arduino, but that was pretty straightforward. That's a very readily available module that we just plopped in there. Aside from that, once we had all of our wiring done, as I said before, we wired both the Ys to the same direction and step pins. So because they're running the same axis, so we wanted them to be as close to parity as possible. Um, in addition to that, it was pretty much GRBL installation and universal G-code sender, both of which are fairly straightforward. GRBL, there actually wasn't that much to change. It was really just pin numbers, which was in one file. I think the main difficulty we had with GRBL was making sure we were on the right installation. There were a few times where we accidentally installed GRBL 0.9 and we wanted 1.1. So I would just warn anyone trying to do this, be careful about that. Aside from that, interfaced really, really easily with Universal G-code sender. Obviously, I'm not the most experienced with G-code and CNC controllers, but I would greatly recommend it. It accomplishes everything we needed and was really easy to get started. It was practically like the Arduino IDE where you just click connect on a serial bus and call it a day. Um, Aside from that, it was pretty straightforward. Yeah, I think that was all the technicalities, but if anyone has questions, I know this video was a bit jumping around, so if there's any questions, leave them in the comment and I will do my best to answer them.